There is no ground here. None. Not a single solid inch to put your foot on, anywhere on the entire planet. Jupiter doesn't have a surface in any sense you've ever experienced, and what's waiting for you instead, the deeper you go, gets stranger and more violent than almost anywhere else in the solar system. Today, we're sending a human onto Jupiter, or more accurately, into it, and walking through exactly what would happen as they fall. The deepest layer on this list is something most people have genuinely never heard described before. Stick around for that one. The instant you arrived at Jupiter, the first and most disorienting realization would hit you immediately. There's nowhere to land. Jupiter is a gas giant, made almost entirely of hydrogen and helium, with no solid surface at any altitude you could realistically reach by air. What looks like a surface from space, those famous swirling bands of orange, white, and brown, is actually just the top of an atmosphere that gets thicker and thicker the deeper you go, eventually transitioning into liquid, and eventually into something stranger still. There's no clean line where atmosphere ends and ground begins. You would simply keep falling. And falling into Jupiter means falling into one of the most violent weather systems in the entire solar system. As you began descending through Jupiter's upper atmosphere, you might pass near its most famous feature, the Great Red Spot, a massive storm system that's been raging continuously for at least 190 years, and possibly far longer. The storm is so large that it could comfortably fit Earth inside it, with room to spare. Estimates put it at roughly 1 to 1.5 times Earth's diameter. Wind speeds inside the storm's outer edges can exceed 270 miles per hour, far stronger than the most powerful hurricanes ever recorded on Earth. If you fell into that storm directly, you'd be caught in winds powerful enough to be instantly, catastrophically fatal. But the truth is, even staying away from the Great Red Spot wouldn't save you, because the rest of Jupiter's atmosphere isn't much calmer. As you kept falling deeper, the pressure around you would begin climbing at a terrifying rate. Within just a few hundred miles of descent, atmospheric pressure would already exceed anything experienced anywhere on Earth's surface, and it would only keep increasing the deeper you went. Eventually, somewhere roughly 13,000 miles down, the pressure and temperature would become so extreme that hydrogen gas would be compressed into a liquid state. Keep falling past that, and the pressure becomes so intense that hydrogen is squeezed into something almost unimaginable. Liquid metallic hydrogen, a phase of matter that doesn't naturally exist anywhere on Earth, where hydrogen atoms are compressed so tightly that they begin conducting electricity like a metal. By this point, you wouldn't just be dead. Your body would have been crushed and torn apart by pressure thousands of times greater than at Earth's surface, long before reaching this depth. But the planet itself keeps going, far deeper than where any human body could ever survive. Even before reaching those crushing depths, Jupiter's upper atmosphere hides another danger: lightning storms far more powerful than anything that occurs on Earth. Spacecraft flying past Jupiter have detected lightning strikes with energy levels up to 1,000 times more powerful than typical lightning on Earth. These massive electrical storms occur deep within Jupiter's water-based cloud layers, triggered by similar processes to Earth's storms, just on a scale matched to a planet over 11 times Earth's diameter. A single direct strike from one of these megabolts would be instantly lethal, and they occur frequently across different storm systems scattered around the planet at any given time. Jupiter has the strongest magnetic field of any planet in our solar system, roughly 20,000 times stronger than Earth's. That massive magnetic field traps an enormous amount of charged particles, creating radiation belts far more intense than anything surrounding Earth. These radiation levels are so extreme that even heavily shielded spacecraft have to carefully limit how much time they spend in certain regions near Jupiter to avoid having their electronics permanently damaged. For an unprotected human, exposure to this radiation field would deliver a lethal dose extremely quickly, independent of, and in addition to, the crushing pressure and violent storms already working against you. So even if you somehow survive the pressure and the storms, the radiation alone would still be working to kill you the entire time. So what's actually at the bottom of all this, assuming you could somehow keep falling? For decades, scientists assumed Jupiter had a small, solid rocky core, similar to a scaled-up version of a rocky planet, buried deep beneath all that hydrogen and helium. But data from NASA's Juno spacecraft has suggested something stranger. Jupiter's core might not be a clean, solid ball at all. Instead, it may be a large, fuzzy region where heavy elements are partially dissolved and mixed into the surrounding hydrogen, rather than sitting as a distinct separate layer, more like a thick, gradually blending core than a hard boundary. In other words, even Jupiter's own scientists studying it for decades aren't entirely sure where the atmosphere actually ends and the planet technically begins. There may be no clean finish line down there at all, just an ever-thickening blend all the way down. So here's Jupiter in full. No surface to ever stand on. A storm bigger than Earth that's been raging for centuries. Crushing pressure that would kill you long before reaching the strange metallic hydrogen layers below. Lightning 1,000 times more powerful than Earth's. Radiation belts intense enough to damage spacecraft. And a core that might not even have a clean edge to it. It's less a planet you visit and more a planet that simply consumes anything that tries. Up next, we're heading to Jupiter's quieter ringed cousin. A planet light enough that it could theoretically float in water, if you could find a bathtub big enough. Stick around for that one.